Right, here's the application. The height in feet of an object above the ground is given by this function, and the function that they've given us is that h is equal to negative 16t squared plus 64t plus 124, where t is our time in seconds. Find the time it takes for the object to strike the ground and find the maximum height. Let's find the maximum height first. Now, this is a quadratic, which means it gives us a parabola shape. Where is the maximum located? The maximum is located at the vertex. So we need to find the vertex of this parabola. Okay, so we have our a, b, and c. To find our vertex, we first do negative b over 2 times a, or negative 64 over 2 times negative 16. That gives us, negative 64 over negative 32, or 2. Okay, now notice that is our t, okay? So our vertex is at 2, so 2 seconds is when we reach our maximum. To find the actual height, because that was our other coordinates, we need to plug that back into the function. Okay, so our height would be negative 16 times 2 squared plus 64 times 2 plus 124. Again, use order of operations very carefully. You square the 2 first. 2 squared is 4, and then you multiply by the negative 16. So you get negative 64 plus 64 times 2 is 128 plus 124. And we get 188. So our maximum value occurs, our vertex is 188, which means our maximum height is 2 seconds. After 2 seconds, we reach a height of 188. Is it feet? Yes, it's feet. Okay, so we've answered one of the questions. Our maximum height is 188 feet. That's as high as the object will get, and then it will come back down. After how long will it strike the ground is the second question. Okay, now think about it. If your height is your y value on the graph, where are you going to be? What will your y value be? Okay, remember this is our height, and this is our time. If we hit the ground, where are we? Okay, if you go up and you hit the ground, what's h? Well, h is going to be 0, okay? So to find this answer, we're actually finding our x-intercept. We let our height be 0, because if you're laying on the ground, your height is going to be 0. And then we go ahead and we solve for that. Now, you could try to factor that if you want to. But if you don't, I'm not thinking it does factor, you can always use the quadratic formula. So we do negative b plus or minus the square root of b squared minus 4 times our a is negative 16 times c is 124. All over 2 times a. I'm going to compute the part inside. We have 4 times 16 times 124 is 7,936 plus the 64 squared gives us 12,032. Trying to save space here. Divide that by 2 times negative 16 is negative 32. Okay. So now we're going to go ahead and look for our answer. We have 2 answers here. One of them will be valid and the other will not. We have negative 64 plus the square root of 12,032 divided by negative 32. And we have negative 64 minus the square root of 12,032 divided by negative 32. So we go ahead and we find both of those numbers. One of them may be negative, and that would not be a valid answer. You can't have a negative amount of time. So that's how you know which one to go with. Okay, so I'm going to go ahead and do negative 64 minus the square root of 12,032 divided by negative 32. And I get, for this first one, 5.4 seconds, and which means the other one's probably not going to be a valid answer. Negative 64 plus the square root of 12,032 divided by negative 32 gives us a negative answer, and we can't have a negative amount of time. So our two answers are, how long will it take before it strikes the ground? We set it equal to 0 and solved using the quadratic formula and found that after 5.4 seconds it will hit the ground. And find the maximum height. The maximum height was 188 feet. Okay, and that was after 2 seconds. So a couple of different ways we can apply that. If our height were negative, that would mean it burrowed down into the ground, okay? We can't have a negative time. Here's another application of quadratics. Cost, okay? The cost of toasters to manufacture them is 400 minus 20x plus 0.4x squared, where C is the total cost in dollars and x is the number of toasters they're making. How many toasters should be produced to minimize? And notice we know we'll have a minimum because our number in front of x squared is positive, which means it opens up and has a minimum. Okay, so how many toasters should they make to minimize the cost to the company? So our minimum value is our vertex. We're trying to find the vertex of this function. I'm going to rewrite it a little bit so that it's the way we're used to seeing it with the x squared first, which you can absolutely do as long as you keep the sign of all the numbers and don't accidentally change them. Okay, let's find our vertex, or the number of toasters we need at that vertex, which will be x. Negative b over 2a, so we have negative of negative 20 over 2 times 0.4. Negative and a negative make that a positive 20, and 2 times 0.4 is 0.8. So we do 20 divided by 0.8, and we get 25. Okay? We could plug that back in to find out what the actual cost would be when we make 25 toasters, but the minimum number they need to make in order to, the number they need to make in order to minimize cost is 25 toasters, not a real big production. Here's one more example. Here's the profit. They would to maximize their profit. Give me a second to look through that question. Here is their profit function. Okay, how many items does the company have to sell each week to maximize? And again, this is quadratic, so we know its maximum will be wherever the vertex is. So again, we want to find the vertex, negative b over 2a. Our b is 60, so we have negative 60 over 2 times a, which is negative 0.5. So I have negative 60 divided by 2 times 0.5 is 1. In this case, negative 1 because we multiplied by a negative 0.5. So I have negative 60 divided by negative 1 is just 60. Okay, so they need to produce 60 items to maximize their profit. If it asked what is the maximum profit, we would go ahead and substitute 60 back into our function and find the profit. So here are a couple examples of application problems involving quadratics.